or not to be. He had one chance to kiss the bride.
Luxray Production.
Good afternoon. Yebo Tutor. Today we'll be looking at Newton's laws, and I'm using 2021. It was a question paper for May, and we'll be looking at question 2, which is Newton's laws. And before we get or dive into the questions, we just do a few concepts on Newton's laws that you should at least know before you dive into Newton's laws. Now, especially on the statement, they will obviously say this. You'll find this kind of statements on statement like a rough surface. So when you hear the word rough surface, that means you already know that. Then you must know that there's friction on it, and if you see a statement that says a smooth surface, that means that surface is friction free, so there's no friction on that surface. Also, just a few concepts. If you have a block on a horizontal surface and they tell you that it's on a rough horizontal surface, and they tell you that it's standing still, it means it's not moving. Now remember, we have two different kinds of frictions. We have the kinetic friction, which only works when the block is in motion, but when the block is standing still, we have what we call static friction. Now remember, said when the block is in motion we have kinetic friction, and when it's standing still we have what we call static friction. Now to calculate the kinetic friction, we have a formula which is the coefficient of kinetic friction times the normal force. Which the normal force is the force that acts perpendicular to the surface. Now when you dive into the question, it says an 8 kg block is on a rough horizontal surface. Now we said when you hear the word rough horizontal surface, that means you already know that we have friction. That means the surface has friction. It says an 8 kg block is on a rough horizontal surface and is connected to a 2 kg block by a light inextensible string passing over a frictionless pulley, as shown below. Now it says also the 8 kg block moves at a constant speed when pulled by a 29.6 Newton horizontal force to the right. The frictional force acting on the 8 kg block is 10 newtons. Now before we also dive into the questions, before we even go and see what the question is asking us, let's first analyze the statement. Now from the statement, we're gonna do for both blocks. Now for the 8 kg block and the 2 kg block. Now for the 8 kg block, we know that there's a force, it's being pulled at a constant speed of 29. The force that's applied is 29.6 newtons to the horizontal. So that means we know that the 8 kg block has force applied. The 8 kg block has force applied of, it has a force applied of 29.6 newtons. Now also regarding the 8 kg block, we've been told that there's a frictional force acting on it of 10 newtons. So that means we also know, and because we know that we told that it moves at a constant speed, that means the kinetic friction is acting on it. It's not the static, because static friction only acts on a block when a block is not in motion. So we have been told that it has a frictional force of 10 newtons. So that's what you know about that's what we've been told about the 8 kg block. Now regarding the 2 kg block, we are told that it's connected to the 8 kg block by a light inextensible string which means that we know there's tension, but we're told that it's on a frictionless pulley, so there's no friction acting on the 2 kg block. The thing we have on the 2 kg block, it's tension. Now also on the 8 kg block we have tension as well. Now, but the tension is unknown. Also, the tension is unknown in both blocks. So now we move on to the first question. The first question states Newton's second law of motion in words. Now we know this is where you must know your definitions, because in metric given definitions on how to say them, especially on the question paper, you're given certain words that you must say in a definition to write them in a question paper. So you don't just take a definition from Google and write it on your question paper when writing your test or exams. So now, but you know that state in Newton's second law of motion, you know that, what is it? If a force acts on an object, the object will accelerate in the direction of that force, and force will be directly proportional to the it will be directly proportional to the force, to net force acting on it, and inversely proportional to the mass. And so now for the 2 point, now it's also important to know your definitions, especially while doing physics, because before we start every question they will ask you a definition. Definition is always 2 marks. So at least even if let's say your question paper consists of 8 questions, and obviously you know question 1, that will be your multiple choice, then you will have 7 other questions remaining, and on those 7 questions, by the start of every question you will get the definition. So that means when you've studied your definitions, already you have 2 marks of each question, which means you already have 14 marks, and those 14 marks completely free, because you just read, know your definitions, and you write it. Doesn't even need you to do anything difficult. So now we go to question 2.2. Question 2.2 says draw a free body diagram for the 8 kg block. Now we look at the 8 kg block. The 8 kg block is on a horizontal surface. So that means what we are given, as we can see on the screen, we have a force acting horizontally. We have a horizontal force of 29.6 newtons. And this is the force applied. And we also have, what we are told also is that we have a frictional force. Which we know that the frictional force always opposes the motion of an object. So the object that you're being told is it's being pulled to the right. That means we know that the frictional force will be acting to the left, because the frictional force opposes the motion of an object. And we also have our normal force acting perpendicular to surface. We also have our weight, or the gravitational force. And now also, one thing you must realize about question papers is that when they ask you for a free body diagram, the marks that you see always indicate how many vectors you're gonna have, how many forces you have acting on the object. So if we look at this one, we have 5 marks to intuit. We have 5 marks for the free body diagram. That means in our minds we already know that because we have 5 marks, that means we must have 5 forces. Now, as you can see here, we have only wrote 4. We wrote our kinetic friction, we wrote our weight, we have our normal force, and we have our force applied. Now, also when you look at the 8 kg block, you can see that we know that it's connected to a 2 kg block by a light inextensible string. So that means there is tension as well. So now once you have this, once you have your free body diagram, as you can see, we have 5 forces and the mark allocation is 5 marks. So you should always check your mark allocation, because your mark allocation always indicates how many forces you're gonna have. Now this is for the 8 kg block. Now let's do it for the 2 kg block. They didn't ask us for the 2 kg for the free body diagram for the 2 kg block, but let's do it either way. So if we were being asked to draw a free body diagram for the 2 kg block, we would have our tension, which connects the 2 kg block to the 8 kg block, and we would have our friction, sorry, not friction, you have our weight, or the gravitational force pulls the block, that pulls the block downwards. And because we know it's a frictionless pull, we won't have any friction, and that will be it. For the 2 kg block, we only have 2 forces acting on it. We only have the tension and the weight. Okay, now moving on. Question 2.3 says calculate the tension in the string. Now, from our free body diagrams, we can see that on our 8 kg free body diagram, we have tension as well, and on our 2 kg free body diagram, we have tension as well. So that means we can use two ways to calculate the tension in the string. So firstly, we're gonna calculate the tension using the 8 kg block. So when we use the 8 kg block to calculate the tension, now on the 8 kg block, we have the force applied, which acts to the right, and we have the tension opposing it, and we also have the kinetic friction, which all equals to ma. Oh, and I almost forgot one of the most important things we didn't analyze from the statement. On the statement, it said that the 8 kg block moves at a constant speed. You can even see the constant speed is highlighted. So the minute it tells us that the block is moving at a constant speed, it already tells us that our acceleration is 0 meters per second squared. So that means there's no acceleration. Our acceleration is 0 meters per second. Now that we've said that, we can go back to our question. Now when we calculate, we're still looking for the tension. Means we're in question 2.3, calculating the tension on the string using the 8 kg block. Now the 8 kg block we saw from our free body diagram. So we have force applied. Now remember, when you're calculating, we're using the horizontal forces. Now in the horizontal forces, we have the force applied, the tension, and the kinetic friction. And we already know that our acceleration is 0 because the block is moving at a constant speed. So Then our force applied, we're given that it's 29.6 newtons. Our tension, it's unknown, that's what we're looking for. And we are told that our kinetic friction, that's 10 newtons. And our mass, that is 8 kg. Our acceleration, that's 0. So that means our right hand side will have 0. Then we have 29.6 minus 10, which we get 19.6 minus the tension is equals to 0. And you solve. Then you take t to the other side. Then you get your tension is equals to 19.6 newtons. So that means we calculate our tension and we got that our tension is 19.6 newtons. Now we said we could calculate this in two ways. We said we could calculate it using the 8 kg block and the 2 kg block. Now to prove that we can calculate the 2 kg block, let's use the 2 kg block. Now for the 2 kg block, we said for the 2 kg block, as we saw in our free body diagram, we only have two forces acting on it. And those forces acting perpendicular, which are tension and the gravitational force or the weight. So now, because of that, we can say tension is equals to mg. Now, once we have this, our tension will be our 2 kg block times our gravitational constant, which is 9.8, and 2 times 9.8, we get 19.6 newtons. I hope everyone is still with me. Hope nobody's lost. Now, moving on. 2.4 says, statement says the 29.6 Newton horizontal force is now increased to 50 newtons. So that means instead of now using the 29.6 newtons as our force applied, it has now been increased to 50 newtons. So from that statement, we can see that nothing has actually changed except the force applied. So everything is still the same. Our friction is still the same. Our tension is still the same. Oh no, it will change. But from there, we can see that the only thing that has been changed from the statement above, it's our 50 newtons. It's our force applied, which is 50 newtons. Now, already you can see if you change a force, that means other things are going to change as well, because the block was moving at a constant speed with a force of 29.6 newtons horizontal force applied. Now the force is increased. So if the force is increased, that means, we can see that the block will now move at a faster pace than it was before. It means the block will accelerate. So that means now we won't treat it like we treated it before the force was increased. It means now we don't have a constant speed. It means our acceleration is not 0. So 2.4.1, it says calculate the magnitude of the acceleration of the 8 kg block. As you said, because now we had a smaller force, now it's increased, we have a bigger force, and that smaller force was making the block to move at a constant speed. Now a bigger force is applied. So when a bigger force is applied, that means our block will accelerate. It means our block will take pace, will increase the pace. So because that will increase, that means we have acceleration. That means the block will accelerate to the right. So now the question says calculate the magnitude of the acceleration of the 8 kg block. Now to calculate this, you're gonna use simultaneous. Now firstly, say write 8 kg block, the 2 kg block. Now we analyze the forces that we have again at 8 kg block. We have the force applied minus the tension minus the kinetic friction, all equals to MA. Then on the 2 kg side, we have the tension minus the mg, which is equals to, MA. Okay. Now that's settled. We have tension minus mg is equals to MA. Now for the 8 kg block, we have now our force is increased because we already know that we no longer have the 29.6 newtons as our force applied, but it's now being increased to 50 newtons. So that means we have 50 minus our tension. Now we can use the same tension we had before, because now our force has been increased, speed has increased, we now have acceleration, so tension doesn't remain same. Now we have 50 minus t minus 10 newtons, which is equals to our 8, which is our mass, times our acceleration, which is unknown, which means that's what we are looking for. So we'll have 8a this side, and this will be tension minus our mass times 9.8, which will equals to our 2a. I hope you're all still with me. Okay. So now we said we are doing simultaneous. We have our forces for the 8 kg block. We have our forces for the 2 kg block. Now the remaining thing to do is to mix the two. As we said, we are doing simultaneous, so we're going to mix the two forces. So now 50 minus 10, we get 40. Minus tension, which is equals to 8a. And then we have our tension minus 19.6, which equals to 2a. Now from here, you can see this minus t, this is t. So that means this t will cancel out with this t. Then we have 40 minus then you end up having 40 minus 19,6 is equals to 8a plus 2a. Now once we have this, take in our calculators. 40 minus 19,6, and you get 20,4 is equals to 8a plus 2a, we get 10a. Now we're looking for acceleration, so we divide by 10 both sides. Now we get our acceleration. That's 20,4 divided by 10. We get our acceleration to be 2,04 meters per second squared. So we here, just to recap, we had our two forces from the 8 kg block as well as the 2 kg block, and our force applied has now been increased to 50. We still have our friction, and we don't have tension anymore. So now it was 40, and then 50 minus 10, we were left with 40 minus tension is equals to 8a, and t minus 19,6 is equals to 2a. Then our tensions were eliminated. We had 40 minus 19,6, which resulted in 20,4, and we had our 8a plus 2a, which resulted in 10a. So now that we have our now that we have our acceleration, we move on to the last question, which says calculate the tension in the strain. Now, because we use simultaneous, we can use either of the two equations. Now the first equation we have, it's the 40 minus t is equals to 8a, which is 40 minus our tension, which we want, is equals to 8 times 2,04, which is our acceleration. Now we take 8 times 2,04, we get 16,32. We move it to the side, so we do minus 40, so we get 23,68 is equals to, move tension to the side, is equals to our tension. So now our tension, you can see our tension before it was 19,6, now it's 23,68. Let's write it like this. Now tension is 23,68 newtons. This is our tension. Now we can also calculate it using the other equation, which is t minus 19,6 is equals to 2a. Then we have our tension minus 19,6 is equals to 2. multiply by 2 comma 04, which 2 multiply by 2 comma 04, which you have our 4 comma 08. Then we move this 19,6 to that side, so that means we add plus 19,6. Then our tension is equals to 23,68 newtons. As you can see, our tension, then our tensions are equal. So our tensions are the same. We use two equations, we get the same tension. So that means we can see that our acceleration is correct. And that's it with our question paper. That's what we had today. But just to recap, especially on important things we did here, when it comes to Newton's laws, you see, the first question will always ask you the definition, and the other one most likely your free body label diagram. Now it's important to make sure that you get your free body diagram correct, because once you get your free body diagram correct, you're halfway there, because now you will know the forces that are acting, and you will know what values and what forces to use when calculating what you're required to collect, what you are required to calculate. Because you see, even when we calculated our first tension, we could see from our free body diagram here, when we used the 8 kg block, we knew that we had force applied acting to the right, tension acting to the left, and then kinetic friction as well acting to the left. So now sometimes, especially, you can even just make sure that you don't make mistakes, especially with the signs. Sometimes you might add forces that are going in different directions. Now when forces are going in different directions, you don't add them, but the other one has a different sign and the other one has another sign. So as imagine if here, instead of saying Fa minus T, we said Fa plus T, and we said plus again. So you see, we would have gotten a very different value, which is not what's required here. So it's important to analyze a question, but most importantly, it's important to get right your free body diagram, because a free body diagram will show you which forces that you have and which forces that you need to use to calculate what you're required to calculate. So, and just to explain this step, especially for those who's it's their first time seeing it. So basically, you take forces for your 8 kg block, you take forces for your 2 kg block as well, you apply them. Now after applying them, you substitute the values that you have. And now it's important to realize also that when you do this, you see on our 8 kg block, so we chose right as positive, so that means for our 8 kg block, you can see our tension is negative because it's going to the left, it's going the other way around. Now on our 2 kg block, you can't say minus tension, you can't say mg minus tension as well, because we already chose to the right as positive. So that means up is positive, so that is why the tension on the 2 kg block it's positive, the tension on the 8 kg block it's negative. So it's also important, if I had made this one to be positive, that means this one would have had to be negative. And if I decide to make this one positive, that means my FK would be positive as well, my kinetic friction will be positive as well, and my force applied will be negative. So it's important also to know your signs. Now when you reach, after you eliminate both tensions, you take this 40, you minus 19,6, and your accelerations, you add them. So your A's, you add them, you don't subtract, you always add them. So it was 8A plus 2A. It doesn't matter, but your accelerations, you always add them. Okay, yes, and I think that concludes it for today, and we'll view other topics next time. Have a nice week. Thank you.